In the previous video, we figured out a way to find the numbers when we know their AM and GM. In that case, we were given the values of AM and GM. But can we actually derive a formula out of that approach? Can we do this for variables and not numbers? This is what we're going to do in this video. The problem is, if AM and GM of two positive numbers are A and G respectively, these are deliberately left variables, we need to prove that the numbers are A plus minus square root of A plus G times A minus G. Plus will give us one number, minus will give us the other one. So pause the video, try this on your own. Okay, so let's do this together. We know that AM and GM are A and G. Let's assume that the numbers are A and B. So if AM is A, we know that A plus B by 2, that's actually equal to A. And if GM is G, we know that square root of AB, that's equal to G. From these two, we can figure out what the sum and product of these numbers are. We can say that the sum of numbers A and B, that's equal to 2A. And we can say that product of the numbers AB, that's equal to G square. And now what we'll do is, we'll create a quadratic equation whose roots are A and B. So if the sum of those roots is 2A and if the product is G square, the quadratic equation will look something like this. X square minus 2ax plus G square. The sum of roots is 2a and product is G square. Now our job is to solve this quadratic equation. So let's do that. Let's use the discriminant formula. So D, that's equal to B square minus 4ac, that's minus 2a square minus 4 times 1 times G square. And if we simplify this, we get 4a square minus 4g square. That's our D. Let's take its square root. Root D equals to 2 times square root of a square minus g square. Root of 4 is 2 and then a square minus g square comes inside the square root. That's our root D. Now it's time to finish this off. X is equal to minus b plus minus root D by 2a. So x equals to minus b. Here minus b is 2a plus minus root D upon 2a. A here is 1. So that's 2. And we can cancel 2 out. X is actually equal to a plus minus root of a square minus g square. And a square minus g square is just another way to write a plus g times a minus g. So these are our two roots, which are actually the values of a and b. And there's no need to memorize this formula. In most cases, the approach, the technique, the way we solve it is much more important than the formulas that we derive.